Today we're going to be making a salinity meter using parallel copper plates. I'll let you get a close-up look of that so you'll kind of know what it'll look like. First thing I'll do is I'll kind of explain some of the science on how this instrument works. Today, when people measure the salt content in salt water, they do so by running an electronic current through the water. And the reason this works is because when salt dissolves into water, and the salt ions conduct electricity. And how well these salt ions conduct electricity is called salt water's conductance. And we'll be measuring the conductance using the salinity instrument that we're going to make today. Using algorithms and formulas, we'll be able to take that conductance and actually determine how many grams per liter of salt water, grams of salt per liter of salt water there is in the water. So the first thing we'll do is we'll kind of go over our bill of materials. To do this experiment, you're going to need 2 copper plates, 2 M4 screws, 2 M3 screws, 2 M3 nuts, and 4 M3 washers, along with 2 12mm in length M4 spacers. These are all made out of nylon, and the reason we chose nylon is because nylon does not conduct electricity. We're also going to need some electrically conductive epoxy to attach the wires to the plates, as well as an ohmmeter or resistance meter, 2 small cable ties to attach the instrument to the SeaPerch vehicle, and 2 alligator clip wires along with 2 lengths of wire. I chose this length of wire, it's 4 feet, because I was only using 4 feet, going 4 feet down into the water to conduct this experiment. If someone's going 10 feet, then we'll have to use 10 feet of wire, 2 lengths of it. Alright, so in terms of what tools you're going to need about a 3 30-second drill bit to go through the copper plate. And when you'll do that, you'll actually want to put them together and drill at the same time so that the holes line up. You're also going to need a grinding wheel, and you're going to need a small screwdriver. That's kind of what you're going to need. And in terms of how expensive these materials are going to run you, all of these materials at a hardware store you can get for under $7 or $8. With the exception of the ohmmeter, which usually runs anywhere from $15 to $30. In my case, I borrowed it from someone, so it didn't cost me anything. Now, what you're want to do is I cut these copper plates to roughly the dimensions of 1.5 inches by 3/4 inches. Now, what you're going to want to do is you're going to want to go to the grinding wheel and use a set of calipers. And you're going to want to grind these plates so that the dimensions are exact, or as exact as the calipers permit. This is important because in order to compute the conductance of the salt water, you have to have an exact area. And just a little change in the area can throw off your readings by a lot. So once you've ground these to the right length, you're going to do the drilling like I talked about. Drill these. And then you're going to take them back to the grinding wheel and grind off the flash that's left over from drilling. Now, once you've done that, you're going to take your screws and your washer, and you're going to insert them into the hole, slowly, apparently. And you're obviously going to do both screws and washer at the same time. Insert them into the hole as well. Now, the placement of these holes isn't so much important as just making sure that they're not too close to each other and not too close to the edge, because if you drill to the edge, it kind of is a no-no, because then it won't really stay together. So in this case, I actually have to screw the screw in because the hole is a little snug, and I don't want to strip the screw pushing it through. So in place. Now you insert the spacers and then put on the other plate, like so. Put on the washer and screw on the nuts. And these are very small and they're very easy to lose. Now, you don't have to get these extremely tight. You just want them tight enough so that the plates are held firmly in place, and they don't fall off. So, finger tight is just about good enough for this. One thing you will want to do with these plates is you will want to clean them with some rubbing alcohol so that they're kind of primed for the epoxy. Now, once you have these put together, you're going to want to take one end of each length of wire and place it on the outside of each plate. You're going to want to mix the two epoxies together to start the sticking reaction process. Put them on there and let them cure for approximately 4 hours, and they'll be ready to go underwater. And like I said, it's important that you choose electrically conductive epoxy, or no electricity will be getting to your plates. Now, once you have those attached, take your alligator clips, attach one end to each length of wire, and then attach those to your wires of your resistance meter. Take your small cable ties, wrap them around the instrument and also into the netting of the SeaPerch to attach it to the SeaPerch vehicle. Once you've done that, you're ready to test the conductance of the water and use the formulas to find out how much salt content is in your water. One last thing, here's a schematic for this particular instrument. All these dimensions are given in millimeters. I hope you enjoyed my very exciting tutorial on how to make a salinity instrument.